Aloha and welcome to our lecture today. We are going to talk about nutrition. You've heard it said, let food be thy medicine, and in nursing, we know a lot about giving patients medications to treat their illnesses and to control their symptoms. But we also need to know more about how good nutrition can promote good health. And so we're going to spend some time today just learning the basics about nutrition, because I think that's a really good place to start. And so we're going to start the talk off by just looking at some of the organs that are involved in digestion and what those organs do. So we have, if you look carefully as I'm moving through this image here, we can see that this is an image of the head and the mouth. We can see the pharynx and the esophagus. Our esophagus is where food gets transported after we swallow it into our stomach. And if we can remember that the stomach is highly acidic, and it's highly acidic for a couple different reasons. This helps us digest our foods. It also kills germs that can be in the foods. We also have mucus that kind of protects the lining of our stomach. And food does not really get absorbed in the stomach. There's a little bit of absorption that happens there, but really, more importantly, it's the small intestine where most of the food gets actually digested. So from the stomach, food moves into the small intestine. We can see our liver there. Our liver has many functions, but in terms of digestion, the liver, it creates bile, and this bile helps us digest fats. The bile is stored in our gallbladder, and you can see the gallbladder sitting there underneath the liver. And the liver also breaks down and builds up lots of biological molecules. It stores vitamins and iron. And so what happens then is that this bile gets injected into the small intestine, where most of the digestion takes place. Our pancreas is also important. There are hormones that the pancreas secretes that help regulate our blood glucose levels. Our bicarbonate neutralizes our stomach acid. We've got trypsin and chymotrypsin that digest our proteins, and amylase, which helps us digest our sugars. It says polysaccharides there, and that's really just a fancy word for carbohydrates and sugars. And then lipase helps us digest our lipids, which is another word for fat. And so in the small intestine, digestion is completed. There's mucus produced that protects the walls. We absorb our nutrients, most of the water that we drink, and then it moves down into our large intestine, where a lot of water gets reabsorbed and stool gets formed. And then, of course, it gets kind of stored in the rectum, and then when we have a bowel movement, we release the waste products of digestion. So in this process, you know, we take a bolus of food, we chew it, we swallow it, it goes through this process. The leftover contents get concentrated into stool, and then the waste is removed from the body. The nutrients, however, get absorbed through the small intestine and into the body, where the nutrients are used for lots of different really important things that we will be discussing during the course of this lecture. So let's start out by talking about carbohydrates. Carbohydrates are the main energy source for the body. Dietary carbs are starches or sugars, and these are converted into glucose in the body. And the body can use glucose immediately, or it can be stored in the liver and the muscles for use later on. So once glucose is in the bloodstream, We just said it can be stored in the liver and muscles as glycogen for later use. It can be oxidized to produce actual cellular energy, so we have energy to wake up and go about our daily activities. And then it can be metabolized also into fatty acids. And so here's where carbs have been kind of getting a bad rap. In the past several years, people have talked about cutting down on carbs, that carbohydrates are contributing to weight gain. And this is kind of what happens. If you have too much of anything, right, and that includes too many carbohydrates, these sugars in the body, once we've utilized them all and we've stored them all, what ends up happening is that we continue to eat them and take them in, and we've taken in more than we need. They get metabolized into fatty acids where they get stored as fat in our adipose tissue. So we want to remember to teach our patients everything in moderation. And so it's not that we want to completely eliminate carbohydrates, because they are a great source of energy. On the other hand, we do want to know that there are really good sources of carbohydrates that we can eat to fuel our bodies. And then there are not so good sources of carbohydrates, like, potato chips and, crackers and things that have a lot of fat in them, along with a lot of sugar and different types of manufactured oils that may not be very good for our arteries. So, carbohydrates are in the following foods. They're in fruits, they're in vegetables, they're in breads, cereals, and all kinds of grains. Carbohydrates are in milk and milk products. And then, of course, carbohydrates are in the foods that contain added sugars, like cakes, cookies, and a lot of the sweet drinks that we tend to drink, like soda pop and teas and Snapple and just different high sugar drinks as well. And we're going to talk about really the difference between added sugars, which are sugars that are added during the manufacturing process, and naturally occurring sugars that are in the foods and the juices that we drink. So there are two main types of carbohydrates. There are complex carbohydrates and there are simple carbohydrates. And we are going to talk about complex carbohydrates first. This is the dietary fiber and the starch. So we know about starchy vegetables like potatoes and beans and peas and corn. We also can find complex carbohydrates in the breads that we eat and the cereal. And it's also in some fruits and whole grain foods. So we can see over here some images of some of the complex carbohydrates that are pretty much a pretty standard part of many of our diets. Now, the good thing about the complex carbohydrates is the fiber that is in them. And it's important to know that there are two different types of fiber. Insoluble fiber is not digestible. Okay, and insoluble fiber is found in the following: the whole wheat bread, brown rice, wheat bran, lots of, all the fruits and vegetables have insoluble fiber. And it really kind of provides the bulk for our stool because it's what we really don't digest, right? So it's certain things that we take in that don't get broken down into tinier and tinier and tinier pieces and get absorbed through the small intestine. It just keeps moving through the digestive tract and we just expel it as part of our waste. This is our insoluble fiber. But there's also soluble fiber, and this is dissolvable in water. And so the good thing about the soluble fiber is that it binds cholesterol in our small intestine and helps prevent that cholesterol from being absorbed by the body. And so oatmeal is one of those heart-healthy items that we want to put high up on the list for part of our diet. And the reason for that is that we know that eating oatmeal can actually help lower our cholesterol levels, which in turn will help decrease our risk for getting coronary artery disease. And so now you know why Quaker Oats and some other oat types of cereals can make that claim that they are heart healthy. It's because of soluble fiber that's in them. So simple carbohydrates are really the sugars that are found naturally in foods such as fruits, vegetables, milk, and milk products. But it also includes added sugars, and these are added during food processing and refining. So really, what's the difference? We said before that all the forms of carbohydrates that we take in end up getting metabolized in our body into glucose. So whether it's a simple sugar, whether it's a complex carbohydrate, it all kind of gets turned into the same substance once it's in our body. But the difference is that in general, food with added sugars have fewer nutrients than foods with naturally occurring sugars. So let's think a little bit about this. We can see here that there's lots of fruits in this image, and these have plenty of sugar in them, plenty of simple sugars in the fruits, but they're naturally occurring. And the benefit of eating the fruit over, say, drinking a can of soda, which may have a comparable amount of sugar, is that the fruit also has vitamins and minerals and lots of good fiber for us to help promote better health. Added sugars, on the other hand, really are just more of a source for extra calories, and you're not getting the benefit of the vitamins and the minerals. And so when you're reading food labels, it's really important to look for whether or not there are added sugars. And you can do some calculations pretty quickly in your head. 4 grams equals about a teaspoon of sugar. So let's kind of take a look at an example here where we can see a bottle of Tropicana orange juice. This is about a 12-ounce bottle. It contains about 34 grams of sugar. Now, this is not added sugar. This is the natural sugar that's in the oranges and that are juiced. And that's about 8.5 teaspoons of naturally occurring sugar that's in the Tropicana orange juice. And so, one bottle contains about 170 calories. But we can also see that there's some other good stuff in here. We can see that there is some vitamin C. We can see that there's some thiamine, some vitamin B6 and folate and magnesium. And so there are other nutrients in this orange juice that are beneficial to us. If we look at added sugars, so let's say we look at a can of Coca-Cola, we can see that about 12 ounces of Coke has about 39 grams of added sugar. And so really this equals out to about 10 teaspoons of sugar. And so really, there is still a pretty good amount of sugar in this, just like there was in the orange juice. The real difference here is there really isn't another good source of nutrients in the Coca-Cola. It's just sugar. And so we want to also keep an eye on our food labels to see how much they're hiding these added sugars in terms of what they're calling it, right? So they may not just necessarily say on the label, this has added sugars, although the Food and Drug Administration is pushing for that requirement. But it could say that there's corn sweetener, corn syrup, dextrose, fructose, fruit juice concentrate, glucose, high fructose corn syrup, honey, and brown sugar. So these are other ways that manufacturers will refer to sugars that are in some of the everyday products that we consume. So how about protein? Protein is another a substance that we take in when we're eating food. And proteins are part of every cell and tissue and organ in the body, and they're constantly being broken down and replaced. And so protein in food is digested into amino acids. And amino acids are the building blocks that the liver uses to synthesize the proteins that our body requires to perform many vital functions. And so in this next slide, we can see that we've got some amino acids here that have been strung together to make some proteins in the body. And so these repair tissues. These proteins help us heal our wounds. They work to transport different molecules, like as we'll see here in a minute, oxygen on our hemoglobin. They help make our hair and nails and eyes and skin and blood and bones and muscles, and actually even contribute to our clotting cascade, so that when we get injured and we're bleeding, we have a natural way that our body will clot off to keep the blood from continuing to be lost. And so proteins form vital functions throughout the human body. So let's take an example of one. We're going to look at hemoglobin. I mentioned that a little bit ago. Hemoglobin is a protein in our blood that helps carry the oxygen. And so all the red blood cells in our body has millions of little hemoglobin molecules which help carry the oxygen. And so we get oxygen from our lungs. That oxygen molecules can bind with that hemoglobin on our red blood cells. And then that oxygen gets released as those red blood cells move through our body. That oxygen gets released into our tissues and cells. And so clearly we can see a really excellent example of how a protein actually turns into something that actually does something very vital inside of our body. And so there are 20 different amino acids that join together to make all types of proteins that have all different types of functions. But some amino acids can't be made by the body, and these are known as the essential amino acids. So I'm sure you've heard people talk on television and in other places about the essential amino acids. And what this means is that it's essential that our diet provide these acids. And so protein, we want to look at the different types of protein. So a complete protein is really a source that provides all of the essential amino acids. And this is an animal-based food. So here we can see an example of some turkey. And we know that if we eat turkey, we are getting all of the essential amino acids that our diet requires for us. An incomplete protein is a source in which the required essential amino acids are lesser, right? And this comes from really plant-based types of proteins are incomplete. So here we have some kidney beans. Now, that's not to say that it's not good for us to eat kidney beans. It is. But there's something really interesting that we find out, which is that there are certain complementary proteins where we take two or more incomplete proteins, like rice and beans, and we put them together in a meal, and now we have adequate amounts of all the essential amino acids. And so it's really interesting to consider that, you know, culturally, in places where, you know, they have a lot of beans and maybe they don't have a lot of access to animal proteins, they have figured out over time that eating the beans and complementing with the rice really gives you that full source of a protein, a complete protein, once you put the complementary proteins together. So we're going to take a second here to talk about a negative nitrogen balance. You'll hear this mentioned in clinical settings. A negative nitrogen balance occurs in the body when the proteins are being used up faster than they can be made. And this results in the body's need to draw on its own stores of protein for energy. And so this happens when there are maybe dietary imbalances or an illness, an infection, or stress in the body. So a negative nitrogen balance is really a normal state for children because they're growing, right? So children are kind of always outgrowing their protein and iron stores, and so they need lots of good nutrition because they're actively growing. And also pregnant women, right? Because pregnant women are actually growing a baby inside of them. And so this is a situation for children and pregnant women where we would kind of expect them to have a kind of a negative nitrogen balance, which is why it's important for them to have good nutrition. But it also occurs in individuals that are recovering from illness or surgery. And their bodies require extra protein in order to build tissue to promote healing. And so if we have a surgical patient, we always want to make sure that they're getting adequate nutrition and especially adequate protein so that the wound that they have, the surgical incision, and whatever was done in the surgical procedure can heal properly. So what is the daily value that's recommended for protein? So the average male should get about 56 grams of protein per day. And so just to give you an idea, a 3-ounce piece of meat, a beef in this case, has about 21 grams of protein. So, you know, roughly about 3-ounce servings of beef a day would cover an adult male for protein needs. But keep in mind, this little slab of beef here in this image, it's about the size of a deck of cards. It's about the amount that I could hold like in the palm of my hand. So it's really not a really large amount of protein that we really need to take in each day. Another example would be a cup of dry beans, which has about 16 grams of protein. And so again, those dry beans has a pretty good high amount of protein. It's just that we would have to add probably rice to that in order to make it a complete protein. All right, so let's take a little bit of time to talk about fats. There are lots of different types of fats that we can be consuming, and we want to choose fats that are good nutritional sources for us. And so here you can clearly see I have images of avocados and salmon. I have nuts. Over on the other side, we can see French fries and cupcakes and pizza and hamburgers. So let's take a little bit of time and just kind of sort out the different types of fats and what that means for us in terms of nutrition. Okay, so I know this is not a pretty picture. I never really enjoyed looking at pictures of fatty acid chains when I was in nursing school, but I'm not going to ask you to memorize this. I'm just showing you this to kind of teach you a little bit about the difference between the different types of fats. So here we can see a saturated fatty acid on top. We can see a monounsaturated fatty acid in the middle there, and we can see a polyunsaturated fatty acid on the bottom. And if you notice, one of the things that the arrows are pointing to are our carbon chains. You can see that in the saturated fatty acid, there are no double bonded carbon chains, but in the monounsaturated fatty acid, there is one, mono meaning one, and in the polyunsaturated fatty acid, there are two in this image, but there are actually multiple, or poly as in many, double carbon bonds. And so here we can see that the carboxylic acid is the same in all three. Where these fats become different is in their fatty acid chains, okay? And so when we are learning about good and bad fats, understanding these double carbon bonds is important, because we know that the saturated fatty acids really stack a lot better inside of our bodies. The monounsaturated and especially the polyunsaturated fatty acids, they're just not as uniform, and it's because of these different ways that the chains are bonded with these double carbon bonds. And so they do not stack as well, meaning that they do not stick as much in our arteries. And so saturated versus unsaturated, okay? So we said saturated fatty acids, all of the hydrogens are bonded to a carbon, and so these are solid at room temperature. So the best example of a saturated fatty acid is butter, right? If we leave butter out on the counter, it's going to get soft, but it is going to remain solid. Now that's different if we put it in the microwave, it will melt. So what we're saying is a saturated fatty acid is solid, just sitting on the counter at room temperature. A monounsaturated fat has the one double carbon bond that links the fatty acid chain, and it is liquid at room temperature. Now, if we put olive oil, which is a great example of a monounsaturated fat, in the fridge, it does tend to start to get solid, but it is liquid at room temperature. It will maintain a liquid state. So let's take a second to talk about what hydrogenation is. So a monounsaturated fatty acid, which is liquid at room temperature, which is generally a better choice for us to take in as a fat, it can be solidified and actually turned into an artificial trans fat, which can make it solid at room temperature. And so this is a chemical process that requires saturating it with these hydrogens by breaking those carbon double bonds and attaching the hydrogens. So this is what it would look like, okay? If we took a polyunsaturated fat or a monounsaturated fat and we turned it into a hydrogenated fat, and this is done by heating the oil and adding pressurized hydrogen gas and nickel as a catalyst. And so what this process creates is something called a partially hydrogenated vegetable oil, also known as an artificial trans fat. And these are the types of fats that we do not want to eat, okay? Partially hydrogenated oils are created by food manufacturers, and they're used in foods because it's inexpensive to manufacture foods with these types of oils, and it also increases the food's shelf life, stability, and texture. And so you see I have pictures of Twinkies here, and so we know that Twinkies have, a very enjoyable texture. They're very spongy. It tastes really good when you eat a Twinkie. People enjoy eating foods that taste really good. The downside to that is a lot of these foods are made with these hydrogenated oils, which aren't so good for our arteries. And so actually the Food and Drug Administration and the World Health Organization are currently working to ban the use of these types of fats in foods that are manufactured in the United States. The movement began in 2018, and it has not fully caught on yet, because you can go to the grocery store and you can easily identify foods that still contain these fats. And so I put a couple of examples up here. If you look at some of these labels, you can see on the Pillsbury cookie dough, it says partially hydrogenated soybean and or cottonseed oil. I have some Pillsbury prepared frosting in a tub, and if you look at the label, it says partially hydrogenated soybean and cottonseed oil, again in the ingredients. There is also some other foods here that you can see that may or may not have this type of oil in, but I encourage you to take a look at some of the food labels for the foods that you enjoy to purchase and eat with your family, and just start being more aware of these different types of ingredients in the foods. So these trans fats that contain the partially hydrogenated oil really increase our LDLs, which is our bad cholesterol. And this risk factor actually contributes to the leading cause of death in the United States, which is coronary artery disease. And so you can see here there are some French fries and some donuts and prepared cakes that you see like in the bakery section of the grocery store have a tendency to contain these types of fats. Now, that is not to be confused with a saturated fat. Saturated fats are actually naturally occurring fats that are in animal products. So in high-fat cheeses that are made by cow's milk, whole fat milk and cream cheese, meat, butter, ice cream, and ice cream products contain saturated fats which are different than these manufactured fats that we were just talking about previously. And so we can see here some examples of the saturated fats that occur naturally in some of the foods that we enjoy. And also along with that is the dietary cholesterol that comes in fatty foods. Eggs are definitely higher in cholesterol and higher fat cuts of meat and whole milk as well. And so saturated and trans fats are both nutrients that we do not want to get too much of, right? So they're nutrients that we want to take in moderation. We want to look at the nutrition facts label to compare both the trans fat and saturated fat content. And we want to choose the food items that have the fewest grams of trans fat and the fewest grams of saturated fat and dietary cholesterol. And so, again, it's going to be important for you to be able to teach patients about the good food choices as opposed to the choices that may not be so good. And so this bad cholesterol, this LDL, we said was the type of cholesterol that's linked with a higher chance of heart disease. We also have a good cholesterol, and that's our HDL. And this is our high-density lipoprotein, and this is called our good cholesterol because it actually helps carry the cholesterol away from our organs to the liver where it can be removed. And so we actually hope to have lower levels of LDL and higher levels of HDL. And we're going to talk more about that in another lecture moving forward. So we said we've got these mono and polyunsaturated fats. You know, these should also be eaten in moderation, but more importantly, used to replace the saturated fats or the trans fats. These help reduce our bad cholesterol levels in our blood and lower our risk of heart disease and stroke. And we said before these were liquid at room temperature. And we can see some examples here of some monounsaturated fats like nuts, olive oil, avocados, and polyunsaturated fats, which are high in omega-3 and omega-6, like walnuts and flax seeds and fish. And so these are some of the more desirable types of fats that are going to help us maintain a healthier lifestyle. So let's take a little bit of time to talk about vitamins and minerals. Vitamins are organic substances that are made by plants and animals. And animals and humans absorb vitamins and minerals from plants, and then We eat the animals, and we also eat plants for our vitamins and minerals. And we can also, get these vitamins and minerals, like I said, from the animals that we eat. And so if you look at this ribeye steak here, you can see the different types of nutrients that are available here. We've got B vitamins, vitamin K, iron, magnesium, potassium, zinc, all kinds of good things in the animals that we eat. We actually make this vitamin, vitamin K, is made by the bacteria in our large intestine. And vitamin D is another vitamin that we make. The sun's energy turns a chemical in the skin into vitamin D3, which is carried to the liver, and then the kidneys transform this to its active form. So we kind of just assume that when we live in sunny places that we all have plenty of vitamin D, and that's actually not the case. Wearing lots of sunscreen kind of helps prevent this happening, where this vitamin D in the skin then gets turned into this vitamin D that's usable in its active form. So for that reason, we should have our vitamin D levels checked, because we're finding more and more that vitamin D is a very, very important vitamin. And if we are deficient in it, that it can really lead to a lot of different health problems. We know that vitamin D is associated with increased autoimmune problems, as well as increased susceptibility to infections. We've got some vitamins listed here. Vitamin A, which promotes good eyesight, healthy skin. Vitamin B helps with our energy, and it's important for pregnant women especially to get folic acid or vitamin B9. And also vitamin C helps protect our body from infections, and it also helps us absorb iron and calcium. So we need vitamin C in order to absorb some of the minerals that we take in. Vitamin C is also really good for wound healing. The other really great thing about vitamin D is that it helps us absorb calcium for healthy teeth and bones. And minerals, these are inorganic elements that come from the earth and the soil and the water, and these are absorbed by the plants. And so iron is a good example of a mineral. This helps form part of the hemoglobin that we talked about earlier. It gives blood cells their red color, and lack of iron can lead to anemia. Calcium is another really important mineral. We need it for strong teeth and bones, and really calcium plays a role in so many different vital functions in our body. Our bones play many roles in the body. Our bones provide structure to protect our organs, anchor our muscles, and store our calcium. And so adequate calcium consumption and also weight-bearing physical activity like aerobics and jogging, it really helps build strong bones. And this will optimize our bone mass and help reduce the risk of developing osteoporosis later in life. And we know that osteoporosis is when our bones become thinner and weak and they break much easier. And so we store lots of calcium all through our growing up years and into our 40s, and then we really start using the stored calcium that we've stored up all those years after that. And so it's important to get good sources of calcium every day. The calcium that's stored in our bones, we know that it's the most abundant mineral in our body, and it's required for our blood vessels, our muscles, and our nerves to properly function. So calcium is a really important nutrient. Iron is an integral part of many proteins and enzymes that maintain good health. It's an essential component of proteins that are involved in oxygen transport and regulation of cell growth in our bodies. If we have a deficiency of iron, it's going to limit oxygen delivery to our cells. And if we're deficient, we're going to feel tired. We're going to have poor work performance. We're going to have decreased immunity. On the other hand, excess amounts of iron can result in toxicity. So again, we need to know what the normal range should be in our blood, and we need to make sure that we're taking adequate amounts in, but that we're not getting too much, right? Because an excess amount of certain vitamins and minerals can actually be toxic to our bodies. So iron comes from animal proteins, it comes from beans, and if you notice now, you'll see that a lot of the foods that we eat are fortified with iron and calcium as well. The food manufacturers have started fortifying a lot of our foods with iron and calcium, so we can get adequate sources each day. I'm going to take a second to talk about iron deficiency anemia. If we are deficient in iron, I mentioned before, we can have poor oxygen delivery to the cells. We are tired, we can have weakness and decreased immune function. And we can become deficient in a few different ways, right? So if we have a bleeding problem, like let's say we have an ulcer in our stomach and we're losing blood through our stool, we can become have an iron deficiency anemia. We can become anemic. If we have a problem absorbing the iron, so for example, an autoimmune disease like Crohn's can cause inflammation in our intestines, and if we're not absorbing the nutrients that we need, then we can end up with an iron deficiency anemia as well. And then of course we can just have a deficient intake of iron, and that can be the reason why. Women of childbearing age lose a lot of blood each month with their menses, and so women in the ages between 12, 13, 14 up through our 20s have a tendency to be anemic as well, and that's due to monthly periods, blood loss from monthly periods. So we mentioned B9 a little earlier, that's folate, and we said that we want our pregnant ladies to take adequate amounts of folate, and this is important because it's required for DNA synthesis and proper cell division, and we get this vitamin from green leafy vegetables and also from the prenatal vitamins that we give. And in fact, when a woman goes to the doctor and says that she's even thinking about becoming pregnant, we will tend to put her on folic acid before she even gets pregnant, so that by the time she does get pregnant, she's already got plenty of folate on board and she's already being supplemented. And this is the reason why. We know that folate deficiency can result in giving birth to an infant with a neural tube defect or spina bifida. And this was identified by, there was a large population of women in a certain part of the country who had a higher risk for birthing babies that had neural tube deficits. And what they realized was that these women tended to have a folate deficiency in their diet. And so when they identified that these women really did not eat a lot of green leafy vegetables as part of the staple in their diet, they made that connection that, wow, maybe there's something going on with their diet that's putting them at risk for having these babies. And then eventually the research was done and folate became a really important nutrient now that we know we need. Megaloblastic anemia can be a B9 or B12 deficiency, and this is when we have abnormally large red blood cells that are immature. And again, the symptoms are very similar: weakness, fatigue, difficulty concentrating, headache. You can get kind of some heart palpitations and even feel short of breath. And this is usually due to lack of intrinsic factor. And so doctors can diagnose this type of anemia by looking at our blood cell count. So it's important for us to take a second to talk about daily values. The Food and Drug Administration provides daily values, which are the recommended amounts of nutrients that we should be consuming every day. And the goal is to get 100% of the recommended daily value every day. So an example here, we've got potassium. So we need to have a source of potassium every single day of our lives. And for example, the daily value that's recommended for potassium is about 4,700 milligrams per day. And so a banana or an avocado contains about 350 milligrams of potassium, which is about 15% of our daily value. And so when we look at a food label, we can kind of see here that we can see what the percent of daily value is listed in one of the columns. And so on the one side of the column, you can see where it lists the nutrients: total fat, saturated fat, trans fat, cholesterol, sodium, total carbohydrates, added sugars, and protein. It also lists down there some of the vitamins, vitamin D, calcium, and iron, and potassium. So one of the things that's important in learning how to read food labels is that if you see that there are 8 servings in a container and you eat the whole container, how many calories have you consumed? Well, at first glance, you might think that the whole container has 230 calories, but that is actually incorrect, because if you look more carefully, you can see that a serving size is considered to be 2/3 of a cup. So let's say this was cereal, a box of cereal. There are 230 calories in 2/3 of a cup of this cereal. Now, if you were to eat the entire box, what you're really consuming is not 230 calories, but 230 calories times 8, because there's 8 servings in each box, which really means you would be taking in 1,840 calories, which there's a big difference between the two. So I would encourage you to do some of this math when you're looking at some of the food labels and really identify what a serving is. So for example, if you take a box of crackers and you look at how many crackers are in a serving, it might only be like 3 or 4 crackers. And if there's a box full of crackers, we might want to limit ourselves to a cup of crackers or a half a cup of crackers as opposed to eating half of the box, because that's where our calories really start to add up. And remember earlier we said that even in the case of a complex carbohydrate, gets converted to glucose in our bodies, and excess amounts of that is going to be stored as fat in our adipose tissue. All right, so one more quick rule here for reading food labels. This is called the 5-20 rule, and it's kind of a quick guide to looking at percent of daily value. So if you look at this carefully, there's certain nutrients that we want to limit in our diet. We said we wanted to limit the saturated fat. We wanted to limit the trans fat. We also want to limit the cholesterol and the sodium, right? We get plenty of sodium, which is basically salt in our diets. Too much sodium, really. And so we want to actually get more of the nutrients on the bottom that are listed in blue. So that would be vitamin A, vitamin C, calcium, and iron. So with the 5-20 rule, what you want to do is take a look at the percent daily value. So let's take the total fat, for example. It says that the total amount of fat is 18% of the daily value. So that's actually closer to 20%. And that's not a desirable nutrient. So because there are almost 20% fat in this product, This is not really a product that we want to take if we're watching our fat intake, okay? On the other hand, if we're looking at it as a source for calcium, we can see that if it's a nutrient that we want more of, we can see that it's 20% of the daily value for calcium. So actually, this food product is a good source of calcium because it's closer to the 20% for a desirable nutrient. If we look at the iron content, we can see that it's 4%, and so that's kind of on the lower end, right? That's kind of on the lower end of the 520 rule, and so we want more iron, and so it being 4%, not a great source of iron. And so this is kind of how we kind of want to look at food labels in terms of things that we need more of, like iron and calcium. It's got a pretty good source of calcium, not such a great source of iron, but the fat content is closer to the 20, and it really means that it's higher in fat. It's also really high in sodium. If we look at the sodium content, we can see that that's at the 20%. And so this is kind of how you begin to understand reading food labels. So in closing today, our takeaways are that we want to get more of the nutrients that are good for us. We want to limit the nutrients that are not so good for us. And we want to look for ingredients like partially hydrogenated oil and added sugar in food labels so that we can make better choices. We also want to be able to accurately calculate how many calories and fat are in one serving of any type of food that we're planning to eat. So I thank you for your attention today, and until next time, aloha.